All right, here we're on section 6.4 on the maximization and minimization with mixed problem constraints. So here we're supposed to introduce a slack, surplus, and artificial variables, and then form the modified problem. Then we're supposed to write the preliminary simplex tableau for the modified problem, and then find the initial simplex tableau. And then after that, find the optimal solution of the modified problem by applying the simplex method to the initial simplex tableau, and find the optimal solution of the original problem if it exists. All right, so what we have is maximize p equals 4x1 plus 3x2 subject to, and we have those two constraints. Now we have a less than or equal to and an equal to. So our first part is we're supposed to introduce the slack variables and all that. And so let's go ahead and do that. And so A is going to be, we're going to maximize P equals, and we have a 4x1 plus 3x2. Now we're going to add some more stuff here when we start adding the artificial variables and all that. But for now, we'll just say subject to. Now we're going to say x1 plus 3x2. Now with less than or equal to, we're going to add a slack. So we have s1, and that's equal to 24. Now we have x1 plus x2. Now I have to add that artificial variable. That's 12. Now since we added it here, we're going to have to subtract it off here, and we'll just call it MA1. Okay? And so now we have x1, x2, s1, and a1 all have to be greater than or equal to 0. So that's basically our new modified problem. And from there, now what we can do is we can write our preliminary tableau. So the preliminary tableau, we're going to have x1, x2, s1, a1, then we'll have a p, and over here we'll have nothing. We're just going to have, what we're going to have is just have our numbers for this one. 1, and then 0, and 0, and 24. And then we'll have a 1, a 1, a 0, a 1, a 0, and a 12. And down below, we'll take these to the other side. So we're going to have minus 4, a minus 3. Then we'll have a 0, and then we'll have an M, we'll have a 1, and we'll have a 0. Okay. Now, that's our what we call our preliminary tableau. Okay. Now, to get our initial tableau, what we need to do is we need to get rid of the M here. Okay, so we need to get rid of the M in our artificial column. And so what we need to do is we need to take and maybe take a minus M times row 2 plus our row 3, and that can be our new row 3. Okay, so now we have x1, x2, s1, a1, p. And now we have a 1, a 3, a 1, a 0, a 0, and a 24. And we have a 1, a 1, a 0, a 1, a 0, and a 12. And now our bottom row is going to be what changes here. So now we have a minus m minus 4. So we have a minus m minus 4. Then we have a minus m minus 3. We have a 0, a 0, a 1, and then we'll have a minus 12m. Now, the key to remember is when we added this or subtracted this m, we're subtracting off a huge, huge number, like 10 to the sixth or something like this. So this is 10 to the sixth negative and taking off 4 more. This is 10 to the sixth negative, subtracting 3 more, and this is a minus 12 times 10 to the sixth. So now what we have is our initial tableau. So maybe we can write it here. And from here, we can actually start doing our work. And I think what we'll do is now what we have to think about is what is the biggest negative? Well, like I said, this is both of them are both 10 to the negative, 10 to the 6, so they're both huge numbers. This is subtracting off 4, this is only subtracting off 3, so this one is going to be my biggest negative. And so that's going to be what we're going to use. And so now we have to figure out our quotient. And so our quotient is going to be what? Well, it's going to be 21 divided by 1, which is 21. And we'll have 12 divided by 1, which is 12. So it looks like that's going to be our pivot point. Okay. So since that's a 1 already, all we have to do is take a minus row 2 plus row 1, and that's our new row 1. And here, what do we have to do? We're going to have to take and do kind of the opposite sign. So we're going to have to take on this one m plus 4 times row 2 plus row 3, and that's our new row 3. Okay, so when we take this times this row, we'll have m plus 4, and then we have that goes to m minus 4, so the m's cancel, the minus 4 plus 4 cancels, and so that will give us a 0 here, which is what we're looking for. Okay, so let's move to the next page. Oh, and we probably should write our variables here. So this is S1 and this is A1. And so this is going to be our enter and this one is going to be our exit. So we better get all the information here we need. All right, so now going to that, what we have is we have X1, X2, S1, A1, P, and then now we have our S1 and we entered the X1 and then we have our P. Did I put P on the bottom one? I forgot to P here. And then this row stays the same. So it's going to be what? 1, 1, 0, 1, 0, 12. Minus that plus that, that gives us a 0, a 2, a 1, a minus 1, a 0, and a 12. And then the m plus 4 and plus that, that gives us 0. M plus 4 plus that, that gives us a 1. And that gives us a 0. That's going to give us what? Just m plus 4. That's going to give us still a 1. And then we're going to have 12 times the m, so it's going to be 12m plus that m is going to be 0. And then 12 times the 4 is going to be 48. And so that goes to 48. All right. So now if we look here, they're all positive. So we can stop. Okay. So that's our stopping point. And now what we can see is this is going to be our max solution. So max P is equal to 48. When what? Well, when, did I lose the S? That's S1. I guess I must have not wrote it here or whatever. So when S1 is equal to 12, X1 is equal to 12, and then basically we have our X2 is equal to 0 and our A1 is equal to 0. Okay, so our optimal solution basically, which is our last part of the problem, I think, which is, I guess, D. So we've done, we didn't label all these, so this is kind of our B, the preliminary, and this is still part of the preliminary. And then we did, this is kind of the C in the last page, and this is going to be our D. So this is, max P is equal to 48, and when S1 is 12, X1 is 12, and those two are 0. So that's our solution. And really, what we're looking for is X1 is equal to 12 and X2 is equal to 0. And that's going to be our max P, which is 48, because if we go back to our equation, it's just that 4x1 plus 3x2. It doesn't ever have anything with any of those things in our initial problem. And so that's really what we're looking for here. So that would be kind of our solution to part D. All right, so let's stop there and we'll come back for some more.